In this video, we're going to start to make enemies. We're going to use the T01 platformer as a base, make a copy of that folder and rename it as T07 Enemies. And we'll fire that up. I did change my T01 slightly to make a little bit of platforms and blocks and stuff just to more easily demonstrate some of those things. You can if you want, or you don't have to. It's up to you. Okay, so let's start by making a new character body. So new scene, other node, character body 2D, and we'll give it a sprite as well as a collision shape. And we'll give it our usual default texture and shape to match. Excellent. We'll now give our character body 2D a raycast 2D as well. So we'll search for raycast 2D. So what the raycast does is it will probe in a certain direction. So it'll send out a ray and see, hey, what's out there. It's kind of, you can think of it as like sending out a little laser and seeing what it hits. And so why I want this is so that I know for my enemy, I want it to walk back and forth, but I don't want it to walk off of a platform. I want it to, when it gets to the end of the platform, say, hey, there's nothing down there. There's no land beneath me. Let's turn around and walk the other way. So that's why we're going to use the raycast for. Let's give it a script. And let's give it a little bit of code here. Var speed equals 80. You can make your speed what you want. And var direction equals 1. So we have basically left and right. Right is +1, left is -1. We'll give it a physics process. Sorry, let me enlarge so that we can see more easily. Func physics process delta. So if not, and we'll grab the raycast over here, dot is colliding. Is colliding is that thing that sends out that laser beam to see, hey, is there something in front of me or not? And if there isn't, what are we going to do? We're going to say direction times equals -1. So multiplying my direction, remember right now my direction is 1. And so if I multiply that by -1, then my direction is going to be -1. So now I'm walking around, my direction is -1. And if I multiply that by -1, I'm going to get +1. So either left or right, and switching direction if I'm not colliding with something. In other words, if my laser beam is detecting nothing, no platform, mid-air, I'm going to turn around. It might be more easier to visualize if we can, let's just go to our raycast. In our 2D view, here's my raycast right here, this little thing, this little laser beam, and I can put it wherever I want to detect something. So in this case, I'm going to start by moving to my left, and so I want to detect down here, is this a piece of ground or is this empty air? And so if it is empty air, please turn around. Actually, let's make it like closer to the bottom of my sprite, something like that. And so if there is empty air in that spot, please turn around. Otherwise, just keep on going the same direction. We can adjust this over here, target position. So you can see that I have X and Y, -82, 73. In this case, I know that I'm going to be moving this direction to the left, And so I'm just going to detect on the left. To make it more robust, you would want maybe 2 raycasts, one in this direction and one in that direction. For simplicity in this one, we're just going to have the one. So it can only detect if it's going to walk off when it's moving to the left. If it's moving to the right, it's just going to fall off the screen. That's fine. We're just doing this to learn how it works. Okay, so this is the change in direction. And we also want to flip the sprite. So we go to our, grab our sprite here and dot flip and underscore h equals direction. It's either going to be 1 or -1. Again, in my case, the sprite is somewhat symmetrical, so we're not going to be able to see that. But if you are using a sprite that has a direction or that looks different in the left and the right, then you will see that it flips. All right, excellent. So that part is done. So we'll get the regular movement direction velocity.x equals direction times speed. And so this is kind of our usual stuff. We're only moving in the x direction back and forth. It is a platformer. Direction is either 1 or -1 to know if we're moving to the left or to the right. And speed is 80. Okay. And so that's how many pixels per second that we're going to move. Not per second, but per frame. Next, we need velocity.y. And that is going to be equal to, nope, we're going to say plus equals, so we're going to add 600 times delta. And so this is going to represent our gravity. And so plus equals means that it's moving in a downward. Y, the y is increasing, means it's moving down. And 600 times delta, delta is the frames per second. And so that's how many, or so that's how fast it's going to fall down, basically. So it's not actually going to fall because it's colliding with our platform. But if it were to fall, this is the falling code. Okay, and then move and slide as usual. And then we also want it to bump into the wall and turn around. So we have if is on wall, again, a built-in function to test if it is colliding with a wall. And we want it to turn around. So again, same as we did up above, direction equals, or this same thing, to flip it around. And I suppose we should also give it this one. All right, let's see what happens. Wait, we need to save this. So, oops, I didn't name it as enemy. Well, you'll remember, right? And let's go and put it into our level 2D view chain. And here's our enemy. There it is. And let's say put it here. And let's see if it moves. Okay, so you can see that it's going back, and that raycast we can't see, but it's actually beaming a laser kind of in front, and it's when it sees that there is nothing, then it turns around. And same with the wall, when it detects that it has collided with the wall, it is turning around. And so let's just change the raycast a little bit so you can see what happens if it goes directly underneath like this. So it'll still do it, but of course, the raycast starts at the middle of the sprite. And so it's not detecting anything until the middle of the sprite is over the empty air, but it still works. All right, so that's one way of making an enemy. It's a very good way. I want to show you one more thing. So we're going to make a new enemy, character body 2D. This time, don't forget to rename it Mr. Wu, and we'll say enemy 2, and we'll give it as usual sprite 2D and collision shape 2D. Want to give it also a timer, and we'll all make that childs of the root node like so. In the timer, let's set the wait time to be 1 second. One shot is on, auto start is on, so it's going to start timing as soon as the node is created. So basically it's going to be created at the beginning of the game here. Sprite, let's give it a sprite. Let's give it our default sprite. Let's make it a little different color so we can distinguish it though, and we'll make it something like that, and let's make it actually a little smaller. Little tiny enemy. Oops. Something like that. And let's give it our collision shape. Great. All right. So next we're going to give it some code. Script. Okay. We'll make this one move slow. Can't make the enemies move too fast. The game will be too hard. Direction is 1 and var. We're gonna make a new variable and we'll call it is moving. So we want to know basically, is the thing moving or not? So this one we're gonna do random movements basically. So whenever we're using random stuff, we need something called the randomize function. Yeah, basically this randomize makes sure that every time we run the game, it doesn't follow the same algorithm and have the same random numbers generated. It'll generate different ones every time. Okay, let's get our physics process. So basically, if it is moving, we're going to keep on moving. Velocity.x equals direction times speed. This is the same as we usually have, and we have our gravity plus equals 600 times delta, and move and slide. All right, let's get the timer. So if the timer runs out, so basically 1 second is over, we need to connect the signal. So we go to our timer node, go to the node tab and get our signal of timeout, connect that to the enemy2 script. And we have this function now appearing. And of course, the signal appears there as well. Okay, so what are we gonna put when the timer is over? We're gonna say is moving times it by -1. So is moving, to review, was +1 up here. When the timer is over, we're going to make a -1. I mean, we're going to change the sign basically. If it's positive, we'll make it negative. If it's negative, we'll make it positive. Okay, and then we're going to have if is moving equals 1. So if it's positive, we're going to switch the direction. And then we're going to reset the timer. So we grab our timer from the scene tree, but we're going to reset the wait time, or we're going to set a new wait time. So we could set this to any number, but I want a random number. So I'm going to use the random function, randf.range, randf_range, excuse me. And we'll say between 1 and 3 seconds, 1.0 to 3.0. And then after that, all we do is start the timer again. So this function and this function are kind of working in concert. This function is setting up, like, basically is setting this is moving variable to whatever it is. And in this function, only if this is moving variable is positive are we moving. If it's negative, then we're not doing anything. We're not doing any of this stuff. We're just staying still, I guess. And so the is moving once the timer times out, then we're changing it from positive to negative. And then so we're saying, so it's now negative. So if is moving equals +1 is not true. So we're not going to do that. So we're skipping this line and we're going to here, basically start the timer. So the timer is going to time for some time between 1 and 3 seconds. We don't know, it's random. And then when the timer is up again, then we're coming back here and doing all this again. This time is moving is negative. Times it by a -1, it becomes positive. Now is moving is positive. And so we're doing this. Direction is switching. So we're going from left to right or right to left. This is now positive, right? And so now we're starting the timer again between 1 and 3 seconds. So it's going to move. And so this is running all the time as well. This physics process runs all the time. Every frame of the game it runs. And so is moving is now positive. It's moving until the timer runs out, in which case this all happens again, but is moving is negative. So yeah, I mean, you kind of have to think your way through this kind of logically. It is maybe a little bit complicated to get your head around, but if you kind of play the different scenarios through, you'll see that it kind of makes sense. At least hopefully. Let's try it out and see. And let's go to our level and add our enemy with the chain. And we'll put it maybe down, say down here. Don't make it collide, otherwise it won't move. Let's see. All right, so it moved for 1 second. Now it stopped for a random amount of time, moved the other way, stopped for a random amount of time, moved the other way, stops for a random amount of time, moves the other way. I think it's random. It is maybe a little, yeah, it moved a little longer that time. I guess what we could do to make sure is to go back into our enemy 2 code and script and make it, instead of between 1 and 3, we can make it say 1 and 10. That way it can have some really long ones. We'll try that again. Yep, so it stops for quite a long time, still not moving, still not moving, still not moving, and now it moves for a relatively short amount of time. This time it's moving for a much longer amount of time. Yeah, pretty sure the random is working. And so we have 2 different ways of programming enemy movement. Great, so that's all for this tutorial. See you in the next time.